Hello friends, this video on basic concepts of chemistry part 13 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 12. Let's talk about percentage composition. It is the ratio in which the constituent present in a given compound. For example, if you see water has H2O, correct? So hydrogen is 2 into 1. Molar mass of hydrogen is, if you see, molar mass of hydrogen is 2 grams and oxygen is 16, that is 16 grams. Correct? So if you take 16 plus to 18, if you take, let's suppose, if we take 18 grams of water, in this we will find that 2 grams of hydrogen and 16 grams of oxygen. Correct? If you take 18 grams of water, it will have 2 grams of hydrogen and 16 grams of oxygen. Why? Because it will have 2 moles of hydrogen, 1 moles of oxygen. 2 moles of hydrogen is nothing but 2 grams and 1 mole of oxygen is 16 grams. Correct? Thus, if you see, my mass percent of hydrogen in this case will be my 2, because there are 2 hydrogen, by total weight, that is 16 plus 2, 18 into 100. This will be your mass percentage of hydrogen. And if you talk about mass percentage of oxygen, this will be 60 by total is 18 into 100. Correct? This guy will come out to 11.18% and this guy will come out to be, I think, 88.79%. So these are my percentages. So if you see, this is my percentage composition of hydrogen and oxygen. That's how we find. So in any compound, we can find the ratio of the constituents of elements. So in this case, if you see, this guy is 11%, this guy is 88%, hydrogen and oxygen by mass. Correct? And that's how you talk about percentage composition. So you have a compound, you want to find how much percentage hydrogen, how much percentage oxygen. So you do this using percentage composition. The information we get generally from percentage formula is empirical formula. We can find empirical formula using percentage composition. And empirical formula is nothing but the simplest whole number ratio of the various compounds. It's the simplest. For example, for me C2H2, the empirical formula will be CH. Right? It's the simplest formula. For example, for C2H6, the empirical formula will be CH3. The simplest one, right? That contains the ratio of various atoms, but not the actual formula. Correct? But the molecular formula, it will show the exact number of atoms. For example, molecular formula will be CH2 or C2H6. That gives you the exact number of atoms. For example, in this case, you know that there are 2 carbon atoms and 6 hydrogen atoms. So there's a difference. Empirical formula will give you the simplest whole number ratio of various atoms. But molecular formula is one step ahead of empirical formula. It will give you exact number of. And to find the molecular formula, the mass, see, please note, if the mass percent of various elements are known, we can get the empirical formula. But to find the molecular formula, actual molar mass of the compound has to be known. We'll take some examples to explain this, that if you know the percentage, then you can find the empirical formula, and if you know the exact mass, you can find the molecular formula also. Let's take one example. So a compound has 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molar mass is this. We have to find empirical and molecular formula. So let's assume we take 100 gram. Let's take 100 gram of this compound. So in 100 gram of this compound, we'll see that my 4.07 gram will be hydrogen, 24.27 gram will be carbon, and 71.65 gram will be chlorine. Right? This will be the composition in the 100 gram. Correct? So let's convert this gram into moles actually. So 4.07 gram of hydrogen is nothing but my 4.07 by 1.08 moles or 1.008 moles. We're converting everything into moles now, MOL, right? Like moles. Why? Because that's how with moles we can find the empirical formula. These many chlorines will have 24.27 divided by the atomic mass of chlorine, it is 12.01 mole of chlorine, carbon, and chlorine will be 71.65 grams of chlorine, nothing but 71.65 divided by atomic mass of chlorine is 35.5 almost mole of chlorine. That is nothing but, if you see, is almost equal to, this guy is 4 mole, this guy is almost equal to 2 moles, and this guy is almost equal to 2 moles, right? That means my hydrogen, carbon and chlorine are in ratio 4, hydrogen is 4 is to 2 is to 2, correct? 4 is to 2 is to 2. That is, you simplify this, hydrogen and chlorine and carbon will be 2, 1, 1, correct? So the empirical formula is, like, carbon first, hydrogen next and chlorine next. So carbon is 1, hydrogen is 2 and chlorine is 1. This is my empirical formula, correct? So empirical formula, we just need the percentage combination. We have the percentage combination in grams, we got this in moles, and we find that this ratio of this percent composition in moles is nothing but my empirical formula. Now I have to find the molecular formula. For molecular formula, I told that molar mass is mandatory. So molar mass is 98.6. Let's find the molar mass of this guy, right? So let's find molar mass of CH2Cl is nothing but, carbon is 12 plus hydrogen, 2 hydrogen into 1, and chlorine is 35.5. So solve this, this becomes 70, 72 and 80. This becomes 35.5 plus 35 plus 14, right? That becomes 45.8. Yeah, 45.8. 5 plus 4, 9, 3, yeah, 49.5. That is 49.5. Yes. Molar mass of CH2Cl is 49.5. Correct. And I have told the molar mass of this formula is 98.96. So if you divide 98.96 by 49.5, you get almost 2. Almost 2, right? That means my molecular formula is nothing but you get the empirical formula and you have this N. That means CH2Cl, here N is 2, that is nothing but C2H4Cl2. This is my molecular formula. So see, the logic here is you have got the empirical formula, but this guy molar mass has to be 98.96 because I'm telling that the compound molar mass is 98.96. That means if you have to multiply this guy with some number, right? So you make it N, and here N we found was the actual molar mass given 98.96 by molar mass of the empirical formula we got N is equal to 2. That means you have to multiply the whole thing by 2, right? So this becomes CH2Cl multiply by 2, that becomes C2, 2 into 2 becomes 4 CH4, and 1 into 2 becomes 2, that is Cl2. C2H4Cl2 is my molecular formula for this. Correct. Let's have some question time. We have to find the mass percent of different elements present in Na2SO4. So the first thing we should do is we should find the molar mass of Na2SO4. So Na2SO4 will find the molar mass. So sodium is 2 into, so molar mass of sodium is 23, plus there is 1 sulfate, 34, 4 oxygen, 4 into 16. This is 142 grams. The molar mass of this is 142 grams. So if we take 142 gram of Na2SO4, right? So in 142 gram of Na2SO4, we'll find that it contains 23 into 2, that is 46 grams sodium, 34 grams sulfur, and 16 into 4 grams oxygen. This is the breakup. If you take 142 grams of Na2SO4, you'll find this many composition, right? So if you want to find the percentage of sodium, that becomes 46 by 142 into 100. That comes out to be 32.4%. If you want to find percentage of sulfur, that is nothing but 34 by 142 into 100, that is 22.6%. If you want to find the composition of oxygen, percentage of O, that is 64 by total is 142 into 100, and that is 45%. Thus we see that we found the percentage composition of all the elements in Na2SO4. Very simple, just find the molar mass and assume that you have this many grams of Na2SO4. This contains 46 grams sodium, 34 grams sulfur, 64 grams oxygen, and then you apply the normal maths. Find the empirical formula of oxides of iron, which has 69.9% iron and 31% oxygen. So again here, let's assume we have 100 grams of that compound, that oxide of iron, because percentage is given. So let's assume in 100 grams of Fe oxide, I am told that 69.9 grams of iron and 31.1 grams of oxygen. Right? This is given. Now let's convert these guys into moles. So 69.9 grams of iron is nothing but 69.9 divided by 55.85, I think, is the molecular mass of iron. This becomes this many moles. Correct? That is nothing but 1.25 moles. If you talk about oxygen, that is 30.1 grams of oxygen. That is 30.1 divided by 60, the molecular mass of oxygen. These many moles. That is nothing but 1.88 moles. That means if you see my ratio of this is 1.25 by 1.88, and that is nothing but 1 by 1.5. And if you further break this, becomes 2 by 3, because I want to make everything whole number. Correct? So 2 by 3 is my ratio of iron and oxygen. So my molecular empirical formula will be Fe2O3. This will be my empirical formula. Molecular formula I don't know, because for that I need to have the molecular mass. It is not given, not even asked also to find molecular formula. So we just have found empirical formula. Very simple. You assume 100 gram of iron, and then you find the grams of iron and oxygen. You then find the moles of oxygen and iron, because that is what will give you the empirical formula. We find the moles, and then we found a better ratio. So this ratio doesn't look good. So you take 1.25 common, this becomes 1 by 1.15, and then you're not happy with this, make it 2 by 3, because that's everything is a whole number. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.